What are you doing?
All right, I'm going to get started here. This is lesson 2, describing data, part 1. So to review, categorical variables are variables that provide groupings that may or may not have a logical order. If they do have a logical order, they're inconsistent between the groups. So categorical variables are qualitative, so you definitely want to remember that whenever you're using them. So just a review question to start, just to make sure you understand the difference between a categorical and a quantitative variable. You can take a moment, look over the options. If you can, put your answer in the chat box. That'd be great.
Stop it.
All right, awesome. Yes, D is not a categorical variable because GPA is numerical based. Gender, dog breeding, color, those are all qualitative variables. All right, so next with one categorical variable. So data concerning one categorical variable can be summarized using a proportion. And the formula for proportion is the number in one category divided by the total number. So the symbol for a sample proportion is p hat. You'll also see p with a little triangle over top of it. Let me see if I can draw it here. P with a little hat like that. So if you be seen like that, I typically write it out because my computer doesn't allow me to draw it. So that's what it looks like typically in homeworks and labs. You'll see that on exams as well. So the sample, to write a proportion for a sample, it'll be x over n, which is the number in the sample divided by the sample size, which is also known as the total number. And it is important to keep in mind that a proportion must be between 0 and 1. So you'll never get a proportion over 1 or below 0. And you can typically you typically see them in decimal form, but you can also write them in percentages as well. All right, let me erase this. All right. So a review question on the proportion there. So use the formula in the last slide to answer this question. Here are some options to select from. So a bag consists of 2 different colored marbles. There are 36 green marbles and 71 blue marbles. In total, there are 107 marbles in the bag. What proportion of marbles are blue? So take a moment, look it over, and put your answer in the chat box if you can.
Stop it. Stop.
All right, good. I'm going to go over it. If you couldn't get the answer, I'll go through a description of it in a second. C is the right answer. So the formula for proportion is the number in the category over total number, which we just reviewed in the last slide. So that would be the number of blue marbles over the total number of marbles, which is 71 over 107, which comes out to 0.66. All right, so we're really going to hit this topic home. So here's another review for you. There are 30 animals on a farm, 7 pigs, 13 cows, and 10 horses. What proportion of the animals are horses? So just another quick quick question, we'll go over it. All right, yes, B is the answer. So as in proportion, we're going to do the category we're looking for, which is horses, 10 divided by the total number, which is 30, and we get 0.33. So next we're going to talk about risk, which is the probability that an event will occur, which you've probably heard of. Risk is a common term that we use. So the formula for risk is the number with a certain outcome over the total number of outcomes. So here's an example below, which is flu risk. So it says 45 out of 100 children get the flu each year. So the risk is 45 over 100 because there are 45 who do get the outcome over the total number of outcomes, which is 100. So it'd be 45% of children get the flu each year. So next is odds. Typically each semester, risk and odds get confused with one another. And the difference is that odds compares the two possible outcomes with each other, and risk only compares one outcome. So risk compares the chances that something will happen, and odds compares the chances that it will versus the chances that it won't. So it compares the likelihood of an event happening with the likelihood that it won't happen. And the formula is the number with an outcome over the number without an outcome, or you can calculate odds if you have calculated risk in the similar with the similar numbers. You can calculate it using risk over 1 minus risk. If you look closely at the formulas, you see that they are similar. So an example below, so we calculated flu risk for children in the previous example, so we can use risk in our formula to calculate odds, which is 0.45 divided by 1 minus 0.45, which in the end we get 0.818. That is the odds of the child getting the flu. So it's the odds. So you see how it's written 0.818 to 1. All right, so here are some visual representations we can use with one categorical variable. So we have a pie chart, which those are very commonly seen in a frequency table. Pie charts, each slice represents one category of the variable, and it becomes more difficult the more categories you have. So you can easily see that it shows the ages of students in the Penn State Math Club, and you can clearly see that 21 is the most common age among them and 19 is the least common age. But when you have more categories, it's more difficult to see the data. And then frequency tables just show the counts in each category of the variable. It's more quantitative, and it shows the percentages as well. So another visual representation is a bar chart, which on the x-axis is the explanatory variable and on the y-axis is the response variable. You'll see these as they can be vertical or horizontal, and they make it very clear to see the data. You'll see these a lot. So next is a two-way table, also called a contingency table. So data with two categorical variables like this can be visualized in a segmented bar chart or a clustered bar chart, which is similar to the previous bar chart, except each bar will be segmented by another category. So next is probability. So probability is the chance that a certain event, we say event A, for example, will occur. So the formula for probability is the number in group A over the total number. So you can kind of see a parallel with proportion even though they're different. So here's an example. I'm going to use marbles again. There's a bag of 60 marbles of 4 different colors, red, yellow, green, and blue. There are 22 red marbles, 14 yellow, 17 green, and 7 blue. What is the probability that a blue marble will be picked out of the bag? So take a minute to answer this question. All right, so depending on the way you round it, I got 0.116, so 0.117 is acceptable as well. I just didn't round. So you take the number in group A, which we're looking for, blue, which is 7, and then divide it by the total number, which is 60, and then you get 0.116. All right, so next is the range of probabilities, and the range of probabilities, a probability can only exist from 0 to 1, so that means if you get a probability of 0, that means an event is impossible, and if you get a probability of 1, that means without a doubt the event will happen, it is certain. So for example, the probability of rolling an 8 on a 6-sided die is 0, because if there's only 6 sides to a die, then there's no chance you can get an 8. So next is disjoint and independent events. So first thing to note with these are they are different from each other. Disjoint events occur at the same time. They never occur at the same time. But independent events are unrelated from each other. So to the right, a Venn diagram shows disjoint events because they never occur at the same time. You see there's no overlap between them. But a Venn diagram can also represent events are represented as circles within a sample space, which is the box. So if they overlap, that means that they occur at the same time. But since they don't overlap in this case, they represent disjoint events. So independent events, they're unrelated, and the outcome of one does not affect the outcome of the other, which is important to know the difference between those two. So an example of these next is if you consider an undergraduate class status, there are 4 of them. A student can be identified as a freshman, sophomore, junior, or a senior. So in terms of disjoint events, being a sophomore and being a junior are disjoint because obviously an individual cannot be classified as a sophomore and a junior at the same time. They're either one or the other. So if you're talking in terms of gender and class status, freshman, sophomore, junior, senior, and males and females, if we assume that there's an equal proportion of freshmen, sophomores, juniors, and seniors, and an equal proportion of men and women, we assume that they are independent events because knowing a student is a man does not influence the likelihood that he will be a senior. So there's no way to calculate, there's no way to say that if you are a girl, there's more chance that you'll be a freshman, a sophomore, a junior, or a senior than any other. So next is a combination of events. So you'll see these a lot with these symbols. The symbols are important to know and to know the definition. So an intersection is just the probability that A and B will occur. It's different from a union because a union is the probability that A or B will occur. So if if A and B do both occur, that does include a union because they can both occur and still be considered a union. So a complement is everything except A, for example. So since a proportion is between 0 and 1, everything will eventually add up to 1. So if you just subtract 1 minus A, that means everything that's not A will be 1 minus A. And a conditional is the probability of A given B. So if B happens, then what is the probability that A will occur? Only if B happens. Okay, so that is all with categorical variables now. So next we'll go on to one quantitative variable. So first we're going to start with the graphs for one quantitative variable, and dot plots and histograms. You'll see these a lot. You definitely want to know these. So dot plots are graphical displays that can be used with one quantitative variable, same as histograms. Sorry, I apologize for the noise outside. The number of dots in a dot plot or a histogram, the bars in the histogram, histogram has bars similar to a bar chart, while dot plots have dots. So each dot represents one case. So in this case, it shows height, and the height in inches obviously represents humans. So each case represents, in this case, one person. On a bar chart, a histogram. On a histogram, the higher a bar, the more cases there are for that certain category. So next is outliers. Outliers are one or more observations within a set of data that may fall outside the general scope of the other observations. So you can see here that most of the observations are over here in this area, but when you go down here, there are less here, so these would be considered outliers over here. So you find outliers on a dot plot, histogram, and then box plots, which we'll be speaking about more next week. So shape is very important. You're going to be focusing on that a lot this semester. So symmetrical distributions are pretty much exactly how they sound, symmetry. So you see how the distribution is similar on both sides from the center. So they're exactly symmetrical in this case. They don't have to be exactly symmetrical, but they're going to be very, very close. A type of symmetrical distribution is a normal distribution. It's bell-shaped. So these normal distributions are not exactly symmetrical as the symmetrical distributions are, but they're in this bell shape that you see here. So sometimes the data obviously will not be this perfect symmetrical distribution, which is the ideal shape that you want the data to be. So that would be when they're considered skew. Let me erase this here. So there's two different types of skewness. There's right skewed and left skewed. So right skewed is when all of the data seems to be occurring on the left side of the chart. And then there's an area of skewness on the right here. Oops, sorry. Go back. So there's an area of skewness on the right over here. Please, because my pen's not working. Okay. So with a right skew distribution, there's a significant area that's spread out on the right side. So that's why it's called right skewed, and all of the data seems to be piling up on the left side. And then vice versa on a left skewed distribution, on the left side there seems to be much less data, and it seems to be piling up on the right side. So those can be kind of confusing. You definitely want to make sure that you know those. Yes, it's very noisy outside. I apologize. The Eagles just won. Everyone's very excited. All right, so next, measures of central tendency. You've probably heard of these before: mean, median, and mode. At least mean. Mean is numerical average, so it's the sum of all the data values divided by the number of data values, which is just one value. It's not divided by all of them. So a sample mean we call X bar, which is, let me see if I can get my pen here to work. So X with a bar on top. Oops. All right. There we go. So that's what it's going to look like. My computer doesn't allow me to do that, but that's what it would look like on Homeworker. But in terms of population mean, which is when you're talking about the parameter you'd use for it, would be mu, which is like a little u with a little line below it. And the formula for a mean is the sum of all the x values divided by n, which is the total number of values. Next is median, which is the middle of the distribution. You want to make sure you order the values from smallest to largest. So sometimes they'll give you a set number of values like 5, 3, 6, 1. And if it asks for the median, you don't just want to pick the middle number out of those. You want to put them in order from smallest to largest and choose then. If they give you even value numbers, you find the two middle values and just take the average of those. So you add them together and then divide by 2, and that would be the median. And then the mode is just the most frequently occurring value. It's just whatever the most is there in the values. All right, so here's an example for mean, median, and mode. So hours spent studying, a professor asks a sample of 7 students how many hours they spend studying for their final. Their responses are as shows. So if you can use the data, you can calculate the mean, median, and mode. Yeah, so just put your answer in the chat box when you're done, and we'll go over it. All right, awesome. So it looks like you guys got it figured out. So in this case, we would say X bar in terms of the mean, but since we're just right now, we're going to say mean. So we're talking about a sample. You're going to use the words X bar when you talk about mean. You'll hear that a lot, so you want to get familiar with that term and make sure you associate that with the sample. And if you're talking about it in a population term, you would use the name mu. So yes, x bar, or the mean, is 8.857 hours. And we just got that by adding up the numbers there and then dividing it by, looks like 7 it was. The median is 9 hours. We're lucky because we already got the data in order from smallest to largest, so we could just cancel it out and see that 9 was the median. And then mode is 9 again. This doesn't mean that median and mode are always equal. We just have 2 9s there, and that is most. So sometimes, before, we just talked about skewness and we talked about mean, median, and mode. And skewness does have an effect on the mean, median, and mode in graphical terms. So if in a symmetrical graph, the mean, median, and mode are all equal. If it is left skewed, the mean is less than the median, and the median is less than the mode. And if it is right skewed, the mode is less than the median, and the median is less than the mean. So it is this way because outliers tend to make the data more, outliers are very sensitive to the mean because the mean is affected greatly by larger numbers or lower numbers that throw it off. All right, so measures of spread. So you see the shape of the graph. We have a way to measure how much that varies, which is called standard deviation. They measure variability. So the definition for standard deviation is the average difference between individual data values and the mean. So in terms of the sample, we denote it as S, or a sigma. And the standard deviation of population is denoted as such, with a little o with a little line through it. The formula for sample standard deviation is the square root of the sum of the sample minus the mean squared, divided by n minus 1. So that's a good formula that you should know. So the empirical rule, you probably heard about this. It's a statement about normal distributions as shown in the image to the right there. Typically, you'll hear about the 95% rule, but you want to know about all three of them. The 95% rule states that approximately 95% of observations fall within 2 standard deviations of the mean on a normal distribution. So otherwise, the empirical rule is that 68% of data will fall within 1 standard deviation of the mean, 95% will fall within 2 standard deviations of the mean, and 99.7% will fall within 3 standard deviations of the mean, seen below. So I have an example, the empirical rule. Suppose that the pulse rates of 200 college men are bell-shaped, so that's normally distributed, which means that you can use the empirical rule here, with a mean of 72 and a standard deviation of 6. So calculate the interval of pulse rates for about 95% of the college men. So that means you're going to use the 95% rule here. And you'll use this formula, mean plus or minus the sample times the standard deviation. And just know that 95% of the data falls within 2 standard deviations of the mean. I'm just giving you the empirical rule to make it easier for you to calculate that. Eventually you won't need it. You'll memorize it by heart, but just for now. So take a moment, figure that out, type your answer in the chat box. Chat box. All right, so here we're calculating, when we use the 95% rule, we can conclude that the pulse rate for 95% of the men is between 68 and 78. So later on in the semester, probably actually pretty soon, you're going to learn how to make conclusions on this. For now, we're just getting the math part down, but eventually make the conclusions. It doesn't hurt to make the conclusions now, but that's what's going to happen eventually. You can use this data to find 95% and 99.7%. I just picked 95 just so we can. Oops, sorry. This was 68. What did I do? I did something. All right, that's fine. So you can practice if you want. Sorry about that. Okay, z-scores. Z-scores are used to describe one observation when you relate it to the distribution of all of the observations. So the formula for that, there's a lot of formulas that you need to know in this presentation. But to calculate a z-score, it's x minus x bar divided by the standard deviation. So the data value minus the mean over the standard deviation. So we're going to practice calculating the z-score in a second. So if you want to write down the formula to use in the problem, you can write that down now. All right, review question. So the average weight of a female border collie is 40 pounds with a standard deviation of 5 pounds. What is the z-score for a female border collie that weighs 34 pounds? So using the formula that we just went over in the slide for a z-score, you can calculate the z-score. Okay, awesome. I'm just going to plug, the answer is D. I'm going to plug the numbers that were given into the formulas to connect some of the dots here. So X that we're given is the data. We're giving that the female border collie weighs 34 pounds. That is the data that we're given. So that's what we're going to fill in for X. 40 is the average weight. See the keyword average weight there? Average weight. So that's what we're going to use as the X bar. And then for standard deviation S, we given standard deviation 5 pounds. So when you plug that into the formula, you finally get an answer of negative 1.2. Awesome. Right, next, percentiles. Oof. These can be very confusing. The best way to master these is practice, definitely. If you get it on the first try, that's very good. If you're not getting on the first try, don't be discouraged. If you keep practicing it, it eventually make sense. I know I definitely did not get this on the first try. It was very confusing. But the percentile is the proportion of a distribution less than a given value. So the best way to put these into perspective is with an example. So with test scores, if a student scores in the 90th percentile on a test, then we can infer that he or she scored better than 90% of the students who did take the test. So that's very, very good to be in the 90th percentile when talking about test scores here in this case. Scored better than 90% of the students, so that's a lot. If 100 students took the test, he or she scored better than 90 other people. So that's very good. There will be many more examples of percentiles throughout the semester, but to get started, there's a good example for you. Next, something you'll see a lot is a 5-number summary. They'll be given to you. It's exactly how it sounds, 5-number summary. So it'll be a collection of 5 numbers given in the order that is here. So the first number will be the minimum. The second number will be the Q1, which is the first quartile. It's also the 25th percentile, which we just went over percentiles there. The third number is the median. The fourth number is Q3, which is the third quartile. It's the 75th percentile. And then the last number is the maximum, which is the highest number you're given. So using the 5-number summary, you'll be able to calculate 2 different things. You'll be able to calculate range and IQR. Range is the difference between the maximum and minimum. Pretty clear. It's maximum minus minimum. And IQR is interquartile range. It is the difference between the third quartile and the first quartile. So it's just Q3 minus Q1. So to kind of put this 5-number summary into perspective, I have a review question here. All right, so 5-number summary. So a teacher wants to examine students' test scores. The 5-number summary for their score is 74, 80, 89, 90, 98. According to the 5-number summary, what is the range? And then can you calculate the IQR? So this is how you will be given a 5-number summary. You can also be given a 5-number summary to interpret the values that you get. So, okay, if you can calculate the range and the IQR, that'd be great. Put the numbers in the chat box when you're done. All right, awesome. Great job, guys. So the range is 98 minus 74, which is 24. And then the IQR is 10, 90 minus 80. Great job. That's it for tonight. If anyone has any questions, I can answer those. If you didn't put your Penn State ID in the chat box, you can go ahead and do that. But otherwise, have a good night. I'm gonna put this recording up on YouTube probably tomorrow after I finish tonight. Last week's I still have to put that up. I'll do that tomorrow as well. You can just type my name. I think Whitney has it. I'll have to confirm with her, but my name should be on the stat website for YouTube with my last name because that's what I use for my YouTube account. So if not, I'll check. But if it's not up there, I'll give it to her for her to put up there.